Fabry Perot interferometer. You can have different variations of this type of interferometer. I'm typically familiar with the used for characterizing lasers in the infrared. So I'll talk a little bit about the types that we use there. So let's say you have, call them Etalons, round cylinder, and then these surfaces here become your mirror surfaces. So the elements of the Fabry Perot, the Etalon, are particularly the input wavelength, lambda, these two flat surfaces we talked about, the index of refraction of the material that we're using, one example is germanium, and the length of the cavity. These are all important parameters that help us calculate the free spectral range, FSR, which is defined as lambda square over 2 times the index of refraction times the length. And this is important because what happens with the light that comes into the cavity, it creates constructive and deconstructive interference, and so the output will be a result of that constructive and deconstructive interference. And the sharpness, if you, for example, instead of a steady wavelength here, input wavelength, if we were to ramp the input of the input wavelength, for example, a triangular waveform, on the output out here, if we were to plot, let's just call it intensity. Let's say we have a detector on this end. Setting the detector here, and we're getting a signal. So, or we could even call this voltage over time. Get something like, without the Etalon, you'd get something like this. Then triangular waveform. With the Etalon, you'd get something like this. Oh, you get these peaks. They kind of exist here too, but you mostly see them resolved here. And so as you're scanning in wavelength space, you're having this constructive and deconstructive effect, which gives you these peaks, and you can identify how much the peaks are moving your FSR in frequency or wavelength space based on the distance between those peaks. And so you can translate between time and wavelength. So in future videos, I'll take this basic concept and apply it to some tunable optical filters I'm trying to better understand. But those are the basic elements of the Fabry Perot interferometer, the Etalon.